Welcome to the Octopus Deploy and Clear Measure Q&A webinar. Paul Stovall and I are super excited to have this webinar with you guys. A little bit of logistics. If you go to octopus.com/Slack, then you're going to get redirected into a custom community channel, hot off the presses, that Paul has created for everyone. And so that will be our chat and Q&A and our back channel. So do us a favor, and whenever you get onto the Slack channel, just do a little bit of an introduction. Just say, hey, I'm here. This is my name. This is where I'm from. I know we have people from so many different locations. So everyone jump on Slack, and that'll be our back channel. Feel free, all of you, to chat even amongst each others. And if someone has a question, throw it into Slack, and we'll pause and kind of try to address some of those along the way. But if one of you wants to address the question, that's great too. So we also have some free offers at the end of the webinar. So stay tuned, and let's kind of jump into it. So Paul, welcome. This is awesome. We're going to get going. How has deployment automation changed since you founded Octopus Deploy?
Yeah, cool. Hi everybody. Thanks for joining the webinar. So when I started Octopus in 2012, back then there were a lot of source control systems, there were a lot of build servers, but there wasn't much at the time in terms of things that would help you automate deployments, especially nothing really mass market the way Octopus was. There were some large expensive enterprise tools, but that was about it. And so in my consulting life, every project you would set up a build server, set up a source control system, and then cobble together a whole lot of PowerShell scripts and other things to try and do some kind of deployment automation. And so when the first versions of Octopus were released, it gained traction really quickly. And I think driven mostly by a few trends. So obviously the move to virtualization and cloud computing means that we have a lot more machines that we're deploying stuff to. And the kind of increasing adoption of Agile at the time kind of meant that we are deploying things more frequently than we used to, all of which adds up to a whole lot more deployments than we used to do in the old days. So Octopus kind of rode that trend. Something that we're seeing now is that in deployment, some way of deploying things from a source control system or a build server or a cloud are kind of table stakes, in the same way it used to be that back when everyone ran a whole lot of websites on one web server and deployed them over FTP, every IDE had to have some kind of right-click publish dialog that would publish a website to FTP. And so, and that's changed. I think everybody's kind of started to understand that automation is important. The thing that we're focused on at Octopus is trying to build the best deployment automation tool, the best tool for the job. So Octopus isn't a build server, it's not a bug tracker, it's not a source control system. We do deployments, and we like to think we do them really, really well. I imagine a lot of the people who have joined this webinar don't have simple deployments, so they probably they're not deploying just one web app to one or two web servers in test and production. Most of the customers we work with have moderately to very complicated deployments, and they're trying to make their deployments across different teams more consistent. And that's the kind of problem space that we focus on. But that's how I think things have changed since we started.
Awesome.
So question for you, Jeffrey, because you and ClearMeasure, I guess, predominantly operate in the Microsoft Azure space. Where does Octopus fit in, and why is Octopus something you're focused on?
Yeah, so ClearMeasure, we're a DevOps-centered software engineering firm specializing in Microsoft and cloud software, and we help our clients create a high-speed and high-quality software factory through DevOps methods. And we're a Microsoft Gold partner in DevOps and in cloud, and so that's our entire world. Our clients have custom software built in Visual Studio and are increasingly moving that software to Azure. And because, starting in 2010, some companies began doing automated deployments, not just continuous integration, but automated deployments and creating production environments from scratch in an automated way and sharing their stories with the industry. And now, I mean, it's been 8 years since the kind of the pioneers had done that. And so everyone sees how accessible it can be to have 100% automated deployments and not have to have weeping and gnashing of teeth over the weekend as you start a deployment on a Friday, and still, Sunday evening, you're still trying to make it work because something broke. And of course, no one in the Slack channel knows at all what I'm talking about. But what we want is software deployments that are a non-issue, that are nice and boring, that just kind of happen automatically. And so um, we realized that was a huge need for our clients. And when Octopus Deploy kind of came out early, it's been the best of breed software, and still to this day has the most options and the most sophistication when it comes to deploying all kinds of .NET apps. And you can deploy all kinds of other stuff with it, but our space is Microsoft, and it has just absolute full coverage for anything that you might want to deploy. And with so many customers already using it, that's been a significant practice for us here at ClearMeasure, and at the same time still growing. So, Paul, some new stuff. Let's share something that folks might not be familiar with yet. What are workers and how they fit into the steps of my deployment project?
Yeah, so workers are new, and it's not something that the name explains particularly well. Not that Octopus itself, I think most people probably aren't sure exactly what the Octopus is all about. But if you imagine you've got this central thing that's coordinating your deployments, and you have all your web, production, tests, servers, and so on. All of those run the tentacle agent, and the Octopus is the thing controlling it. So at least when you explain that, most people kind of get it. With workers, we were kind of struggling to come up with a name that made sense. But if you go to the next slide, I'll kind of explain what they're for. When people in the past would set up a step, like let's say a step to run a PowerShell script or something like that, you had the choice of saying, I want this to run on the Octopus server, or I want it to run on one of the deployment agents, so a production web server, or based on a role or something like that. The downside to the run on the Octopus server setting, and the reason you would use that setting to run something on the Octopus server, is typically when you're doing something that doesn't really relate to any of your dev, test, prod servers, but is sort of maybe something that involves like an API call. So something like I need to go and renew an SSL certificate, or I need to publish something to a platform as a service provider. That's the kind of thing you would typically do just directly from the Octopus server. But there were some security issues that came up with that, because obviously you're executing code now on the Octopus server. And so the way a lot of people worked around that was they would set up some tentacles and give them a role, and then have it run on that role, and that tentacle might be installed on the Octopus server or close to the Octopus server. The thing that didn't work with that scenario, that worked quite well, the biggest downside was you couldn't have multiple tentacles and have Octopus choose just one to run something on. So with workers, the workers are the same. They're actually a tentacle. You install the tentacle agent. But when you add them as a worker into Octopus, you add them to a pool. And so a pool is a collection of workers with a similar configuration. So you might have two pools. One might be a Linux worker pool, and one might be a Windows worker pool, or you might have different pools depending on what versions of various SDKs are installed. And then within the pool, you can have multiple workers, and Octopus will choose just one to run it on, and it'll try and remember that one worker through the deployment. And so the nice thing about that is you can have a step and essentially say, I need this to run on some machine. I don't really care too much about which machine it is, but it has to have these characteristics. It has to belong to this pool. So they should all be configured the same within that pool. And that's where you would use workers from. So examples being, you've got something that is deploying something to Azure and needs a particular version of the Azure SDK. You can add a bunch of those workers to a pool, and Octopus will choose the appropriate one to run it on based on which one is the least busy. Does that make sense?
Absolutely. There's so many configurations before this feature came out where we had to deploy just a phantom NuGet package just to have a process somewhere run something. So it's great to have it as a first-class citizen.
So Jeffrey, so question: how often should you deploy 5 times a day? Is there a number that that people should be aiming for?
Absolutely, 42. No, just kidding. The number depends on your organization. Now we've heard of people deploying 35 times a day and like that, versus one time every 6 months. And DevOps is an extension, essentially, of the manifesto for agile software development. And that thinking, it's do things in smaller batches, and if it's painful, do it more often until the problem is solved and it's not painful. So we know we're doing things in smaller batches. We're bringing in principles from lean manufacturing about building quality in and shrinking lead time and removing bottlenecks, and pull problems and quality upstream instead of passing them downstream, relying on inspections. But when it comes to the number of times to deploy per day, it depends on your business. Now, I hate to leave an answer with "it depends," and so I won't. And so let me give you a few examples. If your business is in marketing or retail or e-commerce, likely the business is going to need to adjust things multiple times a day. And so you absolutely have to have the capability to push out changes to your software multiple times a day just to support the business. Or you may be in a property tax business where you don't need multiple times a day. And you know what, for the pace that they change things, maybe once every several weeks is all that business would request changes, and maybe would go for a month or so and not need to change anything. And then maybe that's a reality in that business. Now, let's come back to technical capabilities. Regardless of how often your stakeholders actually ask you to push that software release candidate into production, you should maintain for yourself the technical capability to deploy at a moment's notice. And so when you put together your pipeline, our guidance is you have a minimum of 3 environment types. The first one is your TDD or test-driven development environment, where no humans are allowed. It's all for test automation. The second environment type is manual testing, manual verification, like you might call it UAT, you might call it staging. And then the third is production. So you should be able to, at a moment's notice, click a button, or enable your stakeholders to click a button and have that release candidate go to your UAT environment. Furthermore, to gain that capability, you should just go ahead and trigger an automated deployment to your first line, we call it TDD environment, straight from your continuous integration build. If you do that, then you have proven to yourself and your team that you have the capability to deploy anytime. And that's the capability that you want. And that way, regardless of how frequently your organization asks you to deploy to production, you know that you can always say yes. And so that's the best answer. And when hooking up your build server with Octopus Deploy, there's no limitation to how frequently or how often you can deploy your software. And so that's the ability that you should be driving towards.
I really love that answer. I think because I think you're right. You read headlines like Netflix deploys so many times a day or something, and I think that's great. But you're absolutely right. That really depends on their business and what they're trying to change. Yeah.
Mm-hmm. Yeah, absolutely. So Paul, there's a great question that came in. We have a lot of teams using Octopus, but each team uses it differently. How can we encourage consistency between teams?
Yeah, that's a good question. So there's a lot of different ways to do this within Octopus, and I've put some screenshots in to kind of walk through them. I think so part of the reason I guess teams will do things differently is, often what we see with customers is they'll have 1 or 2 pilot teams start to use Octopus, and they have some success with it, and then they bring other teams on. And one of the things you learn as you're using Octopus for the first time is that you'll come into thinking about you'll think about the way you want to automate your deployments in terms of the way you used to do them prior to Octopus. So you would think about, when I deploy my web app, I'm going to, I've already got a copy of my app running in production, so I want to back up the configuration file, deploy the new app to it, and then copy the old configuration file back into the new spot. Which is not the way Octopus works. And you will, as you start to use Octopus, you'll kind of learn that Octopus has a lot of opinions about the best way to deploy things, especially websites. And we try and embody those within the software. And as you roll out Octopus within your team, you'll have that group of early adopters who read the documentation and get to know that about Octopus. And then as more and more teams start coming onto Octopus, they'll just kind of start copying the projects that are already there and tweaking them, but they'll kind of bring that old mentality to it. And so part of it's a training thing, as you see different teams using it and starting to use the product quite differently. But there's a few tools that you use, and we like to think that one of our strengths is having lots of teams within a company have somewhat consistent deployment processes, even though the apps will be quite different. So if you go to the next slide, there's some pictures that some features that we'll show. So one thing is multi-tenancy. This is a feature that we'll talk a bit more about later. This feature is used primarily if one of the reasons you're trying to make deployments consistent is you're actually trying to deploy pretty much the same application, but multiple times. Let's say one for each customer, one for each brand that you trade under, but it's essentially the same application, maybe with a little bit of a different configuration. So if that's you, pay attention to the multi-tenancy question that'll be coming up towards the end of this, and we'll go through that in a little bit more detail. But that might be one reason why this consistency thing is kind of important. If you go to the next one, so you can obviously clone projects in Octopus. So some things that we see people do is they'll create one project that's kind of their template for how they deploy particular types of apps. And they'll just call it, they'll put brackets around it or something, so it's alphabetically sorted at the top. And then they'll just clone that each time they need to create a project. That approach works well when over time the projects are more likely to diverge. So if you're like a web agency making a lot of web applications for customers, each app is going to be quite different. It's obviously different source code. The apps are going to look very different. But the basic mechanics of how you build and deploy it are probably going to be the same, but over time they'll vary a little bit. Each customer starts off as a website, but they might add other services and things around it. Having a template project and just cloning it when you need it is a good approach. If you go to the next one, I think this one is step templates. Yeah, so step templates are a way of taking deployment steps within Octopus and essentially making them reusable. So you can take a step like running a PowerShell step or deploying a website, and you can set it up as a template. So you pre-fill all the parameters, all the values for the step, and then you can create your own parameters and reference them from within the step. So instead of having a big PowerShell script that people copy and paste into each of the deployment steps, you can just wrap that up as a template, give it one or two parameters that people might want to select, a few drop downs or something, and then they can use that step from within their deployment. If you've added steps within Octopus recently, you'll probably see a whole lot of community contributed step templates. And if you've got great steps that you've built for things in the past, we'd love you to submit them so we can share them with everybody. But you can also create your own, and a lot of people create their own within their company and then share them for teams to use and encourage them to use them. And then the final thing is, so I wanted to give a shout out to this. So Matt Hodge has been working on a Terraform provider for Octopus. So Terraform is a configuration as code solution, mostly for cloud services. So you can do things like, here's my Azure configuration, or here's my my AWS configuration. Go and provision all this stuff and make sure it matches what's in the code. He's built a provider for Octopus Deploy. As you know, Octopus has an API that everything is exposed through. So this Terraform provider builds on top of that and allows you to declaratively say how you want a project, in this case, to be configured with a whole bunch of steps. So if you've got a lot of projects that you want to keep in sync, this might be a good approach too. So hopefully that helps with some of the consistency issues.
And there was in Slack a question from Kyle in Pennsylvania, do you make them specific to environments or tenants, or strive for generic steps with config?
Yeah, that's a good one. So you can have steps within a process, and you can say this step runs only for this environment or this tenant, and then that step runs for these environments and those tenants. I don't think it's a very good approach. So we built it because there are a few occasions where you need that, particularly a step that just doesn't apply in other environments. So imagine like a manual approval that's needed for production deployments, but doesn't matter for test deployments. That's really what that feature is designed for. As much as possible, you want the exact same steps and the exact same process running in every environment, because how frequently do you deploy to a test environment, and how frequently do you deploy to production? I'd imagine you probably deploy to test a lot more than production. So when that production deployment time rolls around and you're getting ready to deploy, it may have been a few days or a week since you last deployed something to production. If that process that you're running is the exact same one you've been running every hour, every 3 hours in the test environment, chances are it's going to work. If it's very different, if it's got its own steps that only apply in production and other steps that apply in test, your chances of that succeeding diminish.
Yeah.
So Jeffrey, when would I choose Octopus over Azure DevOps or TeamCity? Both of them have deployment features or things that sort of relate to deployments, especially Azure DevOps. When would you choose Octopus?
Sure, and this is a question that keeps on coming in, and I believe it was asked in the last webinar as well. And it's not an either or question. So very specifically, Octopus Deploy is a deployment server. It exists in the space where a build has been performed. We have a versioned release candidate, and now we need to move it through a series of environments and set up those environments, configure it appropriately, and then operate those environments. And so that's the space where Octopus Deploy lives and leads. Azure DevOps services, more specifically Azure pipelines and TeamCity, and even Jenkins or any other build server. If you're going to set up a completely automated DevOps pipeline, you're going to need a build server in addition to Octopus Deploy, okay? Because you need to produce your continuous integration build. And so when you put together your DevOps environment, you're going to need the right mix of top tier products, and you want to choose the best of breed in each area. And so let's take the two mentioned here, Azure DevOps, Azure Pipelines and TeamCity. Both can perform an automated build. They can compile your code, stamp the DLLs with version numbers. They can run scripts to automatically create a test SQL Server database. They can run your unit tests and component level integration tests. And then if that works, we can call Octopack or OctoEXE, and we can package up the NuGet files, or as I like to call the extension, the nupkeg files, and have our set of release candidate. If, for instance, if we just have a database and a website, maybe a backend job, then we're going to have 3 NuGet packages, one for each deployable component. We deploy the website in a certain way. We deploy this backend job, maybe a Windows service or an Azure web job in a certain way, or Azure function. And then we deploy the database. We have 3 things we need to deploy. And so our build server, we need to rely on the build server to create those packages and then push them through the API over to Octopus Deploy in the NuGet feed that's built in for packaging. And so Octopus Deploy provides automated integration through build steps for both TeamCity and Azure Pipelines. Super simple in order to do that. And then somebody asked another question. We'll talk about this a little bit later about how to do full system tests and Selenium tests and security scanning tests, because Octopus Deploy does not run automated tests. It sets up the environments. It can create environments and then attach them with tentacles and then deploy the software to the environments and then watch over the environments and manage and monitor those environments. But to put together your whole pipeline, you need that build server. Now, some of you may be using Azure pipelines and say, well, there's deployment groups. I can do some deployments. Why wouldn't I use that? So Azure Pipelines does have some good support for some of the resources in Azure, namely web applications. And there may be no inherent advantage in that scenario if all you have is a web application and the deployment is tantamount to a file copy. But on the other end of the spectrum, if your system deploys to a virtual machine or many virtual machines, you absolutely need Octopus Deploy, hands down. The complexity of deploying software on a virtual machine is pretty high, and Octopus Deploy's step library is just so sophisticated. It covers absolutely every scenario you're going to run into, and the deployment groups in Azure Pipelines are getting better. But Octopus Deploy has been doing this for so long that if you want to get it working quickly, then just integrate Octopus Deploy straight in with Azure Pipelines in order to avoid doing a lot of your own R&D and lots of PowerShell scripting. So the best of breed implementation that we like is integrating Azure Pipelines with Octopus Deploy. And in 2018, we find ourselves recommending that more than any other solution. We also have a lot of customers come to us that already have TeamCity in place, and Octopus Deploy integrates really nicely with TeamCity as well. But again, you need a place to run and record your test suites. And so Octopus Deploy, when it comes to any type of environment, it handles practically every scenario, every deployment scenario that we've ever come in encounter with. And so that's how I would answer this question. It's not an either or. You need a build server, and then you need Octopus Deploy. All right, so there's a couple diagrams to illustrate. And by the way, I understand that sorry, let me switch. I understand that this is pretty small on your screen. One of the offers that we'll offer, we have a full-size poster of how to basically have a professional Octopus Deploy environment holistically in the DevOps space with Azure Pipelines and Octopus Deploy. And if you'd like this architecture poster, just put a comment in the Slack channel, and we have one of our webinar administrators who will kind of take your name, and we can send over the PDF. It's pretty large, but if you have a plotter, you can print it on 2 foot by 3 foot paper. I think it's architecture D spec paper, and then put it up on your wall. But this is just one of the layers. It's a poster that represents the 4+1 architecture of an automated DevOps environment that combines Azure Pipelines and Octopus Deploy and all the different integration pieces. This happens to be the process layer of showing how source control goes through continuous integration, the build, packaging up with NuGet, and then a 3-level environment pipeline where Azure Pipelines delegates to Octopus Deploy for the installation, and the control comes back for the running of any particular tests. So this is just one part of that poster. Make sure to throw a comment into Slack and request that poster. Here's a little zoom in of the area where we have the 3 different environments and showing how Octopus Deploy deploys to the TDD environment, then the UAT environment, then the production environment. And in each case, we need Azure Pipelines to run a test, run a validation, even if the validation is, hey, I'm calling the API for the system self-check to make sure that it came up and the heartbeat started flowing. But they integrate really nicely. And if you go into the step templates, this is kind of what it looks like. It's literally a step, and you go to the Visual Studio Marketplace, the create and deploy an Octopus release is right there, a few clicks, and it's integrated right in. So if anybody has any further questions about how to do that, just reach out in Slack, and we'd be happy to show you how to integrate the two. But that's your reality. You want to pair your build server with Octopus Deploy, and your life is going to be pretty easy, and you're not going to have to write a whole lot of custom PowerShell, which is really the goal, because you don't just that's a whole lot of extra code, a lot of surface area for bugs, and just automating it with these leading products is going to make your life a whole lot easier. Before we move on, that was a lot of me talking, Paul. Anything you want to add there?
No, I think that was a really good summary of it. I think every every tool that helps with deployments has some kind of off-ramp, right? So if you imagine Octopus has these beautiful steps for, I want to deploy a website and here are the bindings and so on. But then there's always this off-ramp of, if the tool doesn't do what you need, here's the place where you put your PowerShell. And I think that the test is sort of how soon you end up having to dive into that PowerShell and how much of that you end up kind of spackling the gaps yourself. One thing that we, I guess, advise customers on is that choosing a tool is it can kind of go either way. So you could start with Azure pipelines and doing deployments directly through Azure DevOps pipelines. But you may hit that limit in terms of what the product is able to do sooner than doing it with Octopus, at which point the time involved in changing from one deployment tool to another is a lot more than the time kind of involved in initially setting it up. But there are a bunch of things that Azure DevOps Pipelines does really, really well. Some of those, the lifecycle promotion stuff that you talked about, the pre and post deployment steps, approvals, those workflows. Azure DevOps Pipeline models that really well, integrates with the build and the source control system, bug tracking, etc. But when it comes to the actual mechanics, that's where I'm obviously biased, but I think that's where Octopus really shines, and the two tools together, I think, make a really great solution.
Awesome. All right, well, the next question is for you. Should we move our self-hosted Octopus server to Octopus Cloud?
We get asked this a lot. And the answer is really, it comes down to where you're deploying to. So for now, Octopus Cloud runs on top of AWS. And I guess the reason that we built it was we heard from a lot of customers that, Octopus is the only VM that I still have to maintain. So there are customers who everything they do now is a PaaS service, platform as a service thing that they're deploying something to. They're not looking after virtual machines anymore. And so Octopus Cloud makes a lot of sense for them. If you've already got a lot of virtual machines that you're deploying to, looking after, etc., and you can gain a lot of benefits from having the Octopus server located close to them. So if your dev, test, production servers, etc., are all either on-prem in your own data center, or let's say in an AWS environment that's far away from where we host Octopus Cloud, you'll get much faster deployments by just running the Octopus server yourself. And if you're already looking after a whole lot of VMs, the Octopus server isn't, I think it's pretty low maintenance. But if that maintenance is a thing and you're not used to looking after VMs anymore, then Octopus Cloud makes a lot of sense. So that's, obviously with Octopus Cloud, we're keeping it up to date. We'll roll out upgrades faster, so it's a few less things for you to maintain. You don't have to look after the database behind it. We take care of that too. The downside is that chances are going to be a little bit further away from production where you're deploying to, and you may find your deployments are a bit slower as a result of that.
Yeah, absolutely.
So Jeffrey, when a deployment fails, how do you configure rollbacks? Rollbacks is something we get asked about almost every demo, every presentation we do.
Oh yeah, absolutely. And a lot of times this question comes from people who are first getting it set up, and in the manual world, something goes wrong so frequently that you always have a rollback plan, and you're deploying so much that if anything fails, you need to be able to get the older version back in place. In the DevOps world, you deploy much smaller changes. And so if something goes wrong, it's a much smaller surface area to undo. Now, let's just take this one concept at a time. A rollback is a failure. It's a deployment failure. And in reality, nothing in continuous delivery is designed to go backwards. So let's discuss some common scenarios here. So if your deployment project is completely idempotent, for instance, it's just a website, it just has files, you're just doing a file copy, and you replace absolutely everything with every deployment, which is the case with a website that only calls other systems APIs. You can go backwards and forward, no problem. And those are, from a category perspective, those are systems of interaction. You can lump most systems into two different types of software, types of system. One is a system of interaction, and the other is a system of record. Okay. Systems of interaction can change much more rapidly than systems of record. Just think of your ERP, or your big system that keeps track of all the customers, that moves at a slower pace. So in the case of a system of interaction rather than a system of record, you can redeploy the previous release to that environment, and the deployment relies on no previous state. Now, if your deployment is a system of record or otherwise relies on any state that must be preserved from deployment to deployment, then you have to include support for deploying backwards into your architecture, because it's not going to be possible regardless of what kind of tool you use. It's just not going to be possible for a tool to automatically provide this to you. Let me just ask a rhetorical question. Let's say you have an automated deployment process and it's been working for a while, and then it fails. You didn't expect it to fail, but would you then rely on the process that just failed to then somehow correctly go backwards in time and not fail in that scenario as well? Would you really trust that automation, that infrastructure, to automatically roll you back when it just let you down, when it just failed to do the deployment to move forward? So that's just not a scenario that any kind of tools is going to automatically be able to handle. But most of your applications have a database. So let's take that for an example of how you can preserve the ability to go backwards if there's an issue, and design it into your architecture. So for example, let's say you have a phone number field in your database. And once the data, you're going to split out the area code, or split out the pieces of your phone number into individual columns. Once that data is destroyed because you made that database change, or the original column is destroyed in place of some new columns, only a rollback of the entire database is going to enable you to get that back. There's no automated process that says, hey, all those records that I destroyed, go ahead and just put those back. Because unless you saved off all of the data to scripts and then have them ready to do some reinserts, it's just not going to happen, right? And a SQL Server database restore is not something that's going to happen at the snap of your fingers. So for this situation, you create compatibility shims in your shared state, in your database, so that you maintain compatibility of your data and your schema across multiple versions of your application, so that you're architecting your software so that multiple versions of your software can work with the database. And then you could just redeploy the old version if you encounter a failure. And that's not going to be an automatic rollback. That would be you initiating a redeploy of your previously deployed version. And so there's 6 steps to make this happen in this case. Step 1, you modify your database with the new column, the new and the old schema compatibility. So you create the new column, but leave the old columns there, and perhaps you use either some code in your application, or you might just use a SQL Server trigger to keep the data in sync. Step 2, you deploy the application and deploy the database. You deploy the database change, and you have the existing application in place. Then you modify the application to use the new columns. Then you deploy the application. Now you have the new application on the interim database schema. Then you modify the database to remove the old database schema elements, and then you deploy that. And at this point, after those 6 steps, you have successfully moved through what could be a very invasive architectural shift that would have precluded going back in time if something bad happened. So it's also important to have all 3 types of environments in your deployment pipeline, so that your deployment is well practiced before production night, or if you want to deploy to production during the day. It's so important that you practice, that you're not deploying anything new or any novel concepts to production for the first time. You don't want to test anything for the first time in production. Deployment failures should be a very rare occasion, and thoroughly post-mortemed when they occur, so that you can build more quality and more validations into your pipeline. Remember, from source control through private build, continuous integration build, and every environment along the way, you need quality control steps every step of the way. And so that you're not just relying on inspections or testing on the back end to ensure quality, you're baking it into the entire process. You are squeezing the surface area of defects out of the software every step of the way. And so the more you do this, the more rock solid your deployment process and pipeline is going to be. It's very expensive to design the continuous delivery value stream to permit going backwards just because of these types of issues. But even if you attempted to, we rarely see, actually, I've never seen that capability would provide a return on what investment would be needed. And so sum it up, most of the time in production, deployment failures necessitate database restore. And so all this planning and care needs to be in the pre-production steps so that this is prevented. And whether manual or automated, production deployment failures really are never fun. So that's a lot of information. It can be complicated, but what say you, Paul?
Yeah, you speak the truth. There's for Octopus, if a deployment goes wrong, I think the last thing you want, like you said, is a tool then trying to automatically fix things for you. Because if you predicted why it would go wrong, then you would have just not made that mistake in the first place. I think you can use Octopus to do some compensating actions when things go wrong. So for example, you can set up steps in your process that only run if previous steps have failed. So you can use that for something like, okay, the website is broken. Let's at least put up a friendly error page, an up offline file or update DNS to point to a failover website or something so that we can get things running. Or let's send an email or raise an alert. But that's really, I think, the most you can try to do is those sort of compensating actions.
Mm-hmm. Yeah, definitely. All right. So next question for you, Paul. So I have 100 deployment steps in my project. Is that normal?
It is. So the fun thing about being a software vendor is, and you all do this, right? Probably in your own projects too, is you have an idea of how you think customers are going to use it. So in Octopus, the ideal imaginary customer we have in mind has 3 environments: dev, test, production. They have a 4-step deployment process and 20 or so variables. And inevitably, we'll get on a support call with a customer and go through how they're using Octopus, and you go, they'll have like 50 environments, and they'll have a whole bunch of deployment steps and some really and a ton of variables. And the initial reaction is, well, hold on, you're not quite using the tool right. I don't think that's really the case. So usually when we get into these things, there's some reason behind it. Part of that does come back to what I talked about at the start of, you can be trying to tell Octopus a little bit too granularly about how to deploy something. You can be sort of micromanaging Octopus. So if your steps, if you look at them, if they look like, first copy some file here, then move a file there, then rename it. If those are your steps, you're probably not using Octopus at a high enough level. So you should look at things like those built-in steps that do things like deploy to IIS with all the bindings and so on. All those things that you might have in like a 20-step deployment process may be encapsulated by that single step. You can also look at things like step templates within Octopus. And by the way, that a lot of the deployment logic that Octopus uses in those IIS steps and so on, that's actually just PowerShell that we're running under the hood. So we've built a nice UI that's executing a big PowerShell script. And there's an open source project called Calamari that we've published, which is that code. So that PowerShell that we run underneath all of those steps, whether it's deploying to Azure or deploying to IIS or Windows services, that's all open source code. So you can take those bits of PowerShell and roll them into your own step templates and customize them for what you need to do. But if your steps are those really granular steps, then perhaps trying to find ways to use Octopus at that higher level would be the solution. If you've got to a point though where you've got so many deployment steps and they're all fairly high level, what it may indicate is that you're trying to deploy a whole lot of applications at once. So I saw this recently, went to visit a travel company, They do a lot of things for airlines, and they had a whole lot of deployment steps for a whole lot of applications that they were deploying. And essentially, they were kind of moving towards a microservice architecture, but still with one great big deployment. And I think we have a question that kind of relates to how to solve something, a scenario like that later. So we can talk about it then. But those are kind of the two ways you'll have all those steps. The third way is you have a whole lot of conditional steps. So you could kind of look at this 100 steps, but you might find when you deploy to test, only 20 of them run, and when you go to production, 30 of them run, and they all relate to different environments and different tenants. I think if you're doing something like that, again, that's probably not the best way to go about modeling the deployment. Ideally, we would have one process that is as consistent as absolutely possible, and then use things like tenants if you're deploying lots of copies of the same app, or variables to just have slightly different values depending on which steps are running. Hopefully that makes sense.
Yeah, absolutely.
So Jeffrey, I have all these little PowerShell snippets running around. How do I manage them? You just use an email distribution list, don't you? And just email them to everybody?
Yeah, and in my mind, when you got these little PowerShell snippets running around, you manage them by, well, let's see, you got to make sure that they go to bed at 7:30 p.m. and then they're wearing their diapers, and they grow up to be large spaghetti code scripts when they're older. No, so this is a common shift between getting the pipeline functional and then tuning it. So when you're first putting together the pipeline, you're doing so many iterations of figuring out what is going to work and what's the right command line and what's the right script in order for that configuration piece or those sets of files to be just in the right location. And you're discovering what is going to work. And so when you're doing so, you're in the mindset of expedience, and you're using inline scripts. Like I'm going to show, let's see on the screen next. You're using an inline script to just write a little bit of PowerShell and put it right there in the screen and run it. And then you finally celebrate because it works. It did the right thing. And then when do you come and refactor it? Never. And that's one of the catch-22s of cleaning up code and refactoring is when do you have time to refactor? And the answer is normally never. And so you just leave broken windows in your code. And so the key is that you want to recognize that what you're putting together here is, when it comes to automation, you're putting together a software program. Okay. When it comes to deploying to any type of environment, you are creating essentially, to start with, a procedural program. And then as you figure out how it needs to be structured, what sequence of events it needs to be, then you start implementing structured programming, and you start having some branches like, oh, let me make an exception in environment A to exclude this particular step. Or you pull out a variable and you have the variable dynamically create itself via 2 or 3 other variables. And so then you have some branched logic, and then you pull some back into step templates, or you group some of these together, and you start building out your library of things that can be reused. And so just like you would develop in C#, you need to refactor this long procedural set of steps, and many of them may be PowerShell. And so one of the mechanisms for tackling these inline PowerShell scripts is to change it to be a script file inside of a package. And once you have the right PowerShell script, create a PS1 file and actually put it into the Visual Studio project that is being packaged up into the NuGet package. So if it's a Windows service that's being packaged up and deployed to a series of VMs, and you need to do something to configure it to watch the right queues, or to register itself, or whatever it happens to be, then that snippet of PowerShell can be in a PS1 file, and then it gets bundled up into the NuGet package. Now, remember to put in your new spec file, because if it's not a native Visual Studio project file, sometimes it won't automatically make its way into that NuGet package. And if you just create a new spec file, I don't have a screenshot of that, but if you create a new spec file with the name of the project dot new spec, then you can add a files node and you can specify that that new file needs to get bundled up when Octopack builds the NuGet package. And then when that NuGet package, which again is just pretty much like a zip file, is exploded on the target server, on the server that has the tentacle attached to it, that PowerShell file is going to be there. And remember, that PowerShell file, just like you see right here on the screen, can accept Octopus parameters. And in PowerShell, you can also accept environment variables. So you have plenty of ways of getting variables and environment specific tokens into that PowerShell script, even though it was in the NuGet package. Now, we're talking about moving quality upstream. Think about the big picture. You are version controlling this PowerShell script whenever you put it in that Visual Studio project, because it's going to be committed to your Git repository. And now you have less surface area that is versioned separately from your Git repository. And so just in the entire pipeline, there are things that cannot be in the Git repository, and the structure of your deployment project in Octopus Deploy is one of those things. And so you want that to be architectural in nature. You want it to be more declarative, where if you were to look at a pictorial architecture diagram of your entire system, and you would describe what box on that architecture diagram needs to be first, second, and third, well, that's how your deployment project should read. But the implementation details don't need to be like shown on the screen inside all those step templates. The implementation details, like the exact command line with the right command line switches that are necessary, those need to be promoted into files that are stored with your application in a Git repository, and therefore are versioned, because just like the architecture of the application is going to change a lot more infrequently than the actual code. Your deployment project and the structure of it is going, once it's stable, is going to deploy pretty infrequently. However, implementation details will continue to morph. So you want to make sure that implementation details, like little snippets of PowerShell, are not left outside of your version control system. You want to make sure that you evaluate every one of these command lines with switches and PowerShell snippets and get it promoted into a file that's version controlled in Git. Your life will be so much easier. Your Octopus Deploy project will be really rock steady. And when you do need to do some branching and some parallelization in source control, and have parallel environments and use tentacles, instead your mind won't be exploding with all of these parallel dimensions, because Octopus Deploy will happily work with builds produced from any branch, because the structure is the same, although you might have changed the implementation on a particular branch, and therefore the PowerShell script happens to be a little bit different coming through the NuGet package, but it's no big deal because it was inside the package and it came from Git source control. So that's how you manage all of the scripting assets when it comes to deploying and setting up all these little guys.
So you're saying source control the PowerShell scripts, don't just paste them into the Octopus UI like this.
Absolutely.
Do you store it in the same source control as the rest of the project, or is it in its own repository or its own branch or something?
A high 90-something% of the time, the answer is absolutely yes. You may have an exception where you need to store some things separately, but for the vast majority of the people, the answer is a simple yes. You want one Git repository that owns the configuration management for all of the assets for your particular application. All right. So somehow I got 2 in a row.
So Jeffrey, I want to run full system Selenium tests, I hope I pronounced that right, after my initial deployment completes. Where should those test runs go? Are they within Octopus or within some other tool?
Sure. So before we talked a little bit about the 3 different types of environments and also where a build server fits in. Selenium tests can be a form of acceptance tests and can be run from your build server after Octopus Deploy has deployed to your first line test environment, which again, we like to call it the TDD environment. And some of our engineers call it the no humans allowed environment because it's just constantly churning through builds. So Selenium tests are one of these types. You can also run the Wave toolbar for accessibility acceptance tests, ADA accessibility tests for screen readers and the like. You could have test suites with security penetration tests from Tenable.io or abbreviated load tests from Azure Test Plans. So Selenium tests is one of these full types of full system tests where you wouldn't include that test in your continuous integration build because it would likely push your CI build times over 10 minutes. And you want your CI build to be really, really fast and crisp. But you have these other test suites that do need to run, and maybe they take 30 minutes, maybe they take an hour, maybe they take, all night, and you want them to run. And so you need a place for them to run. And this is the type of test suite that a Selenium test would fit into. And so once you add this type of validation or any validation to your deployment pipeline, it always runs and it further hardens your quality control, which is why we're doing this in the first place. And so if I were to kind of show you some screen grabs of what it looks like, we're using the release hub and Azure pipelines on the bottom left, and we can see that we're using the Octopus Deploy step for creating and deploying an Octopus release. And so Octopus Deploy sets up the whole application. Okay, now Octopus is done. The application is up and running. Every part of it, the database, the offline job, website, it's up and running. And Octopus Deploy signals back to the caller, hey, I'm done. And so then Azure Pipelines comes back and says, well, let me download the package for the test suite that needs to run next. Remember, your test suites of this type that have to be executed on a fully deployed environment, they have to be versioned and released as well. So they are packaged up as NuGet files. Okay. Don't take a shortcut. Your life will be harder if you try to take a shortcut and just put those things on a network share somewhere or on the regular artifacts drive. If you're packaging up the rest of the application in NuGet files and you're labeling, version 2.5.3, then your life is so much easier if you take these test suites and package them up in their own NuGet package as well with the exact same version, because then all the time, hey, this is the version of the test suite that goes with my particular application. Okay. And then from there, we can do a little bit of configuration. We see we're updating the value for app URL because Selenium tests need to know what web server to go to. And then we're just using the built-in test runner, which of course has compatibility for in-unit, X-unit, whatever we need to do. And then we grab the results file and integrate it in so that we can see the test results. One very, very simple and abbreviated Selenium test is on the bottom right. And you can see the code that says, hey, driver.navigate to the URL. Let me find the login button. And of course, at the end, we have our assert, driver.title should start with login. And I think in this, we're using the shouldly library. So we have some should, some helper methods. And in the background here, you see the logs that are recorded whenever any type of in-unit or X-unit test executes. And so in this case, we have one Selenium test. So you can see right there, tests, total tests, 1, passed 1, and there we go. All right. So let's quickly go on to the next one. All right. And Paul, I think your video turned off. There we go. Yeah, no problem. So we've turned our monolith into microservices. So I'm scared already, Paul. We deploy each service separately, but QA still likes to test and promote entire groups of releases together. How should we model this in Octopus Deploy?
You scared because of microservices?
Well, the monolith, because that means that this system has been in place for well over a decade. and there's a lot of stuff going on. That this is a complex system, and there's a lot of customers that have these that are implementing Octopus Deploy, and so there's quite a bit of work to do here.
Mm. Yeah, I went to see a customer recently, and they had this problem. So their application was essentially one big monolith, and they were finding that they were getting uh, the trends that were happening in their company, where they were getting more and more customers. So they needed to. They're not a company with thousands of customers; they have sort of hundreds, and each customer had different requirements. So the code kept having to change each time they signed on a new customer, and they were adding more engineers. So they had more people working on this product at the same time. And so for them, the move to microservices made a lot of sense. I think big software, whether it's monoliths or microservices, takes a lot of communication anyway. And I think this kind of move from monoliths to microservices, I always think it changes that communication problem from being a compile time problem to a runtime problem. So the compile time problem is like, we've got all these engineers working on this great big piece of code, and we all have to talk as we're building stuff, and before the code is even really built, and then the changes go out, and you kind of can't have like a team of two people sort of ignoring the rest of the world around them during development. With microservices, you kind of can. So you can take, if you've got a fairly standard way that the different services communicate, the ideal thing, and I think the reason why it's attractive, is you can have these small development teams that focus on particular problems, and kind of execute on those really well. The downside is it still becomes a problem at deployment time. And then there's a school of thought that goes, well, if you're deploying everything at the same time, then you don't really have microservices, do you? And I think there's probably some truth there. So ideally, each team would be building their own service, deploying it separately to dev and test environments, and even into production. And the other teams are working on their services, and those are going out into production whenever they're ready. I think, that's probably where most people doing microservices want to get to. But in the meantime, there'll be a QA process that the software goes through, and this is common when they're, a lot of the time what we see is like the engineers, as they're developing the services, they'll do their own dev test iterations, but before things go to production, they want to kind of test all the versions of this software at the same time. And the reason for that is kind of less of a technical reason and more of just the way the organization is used to changes. They're used to every Tuesday a new version of the software is available. And so we need to
Hmm.
start testing that the week prior and testing all these versions together, because we still haven't quite sorted out the compatibility between all of these services, what dependencies they have, message formats, et cetera, et cetera. So the way you can approach this in Octopus, if you go to the next slide, and we had someone in Slack asking about this too. By the way, Jeffrey, in Slack we had people QAing your PowerShell in the last question too.
Oh yeah,
So
that
with
sample was bad.
intentionally. So with this, what we have is we can have multiple projects within Octopus, and then we can have one project, the Uber project, which is sort of going, when it gets deployed, it's going to take a whole bunch of these child project releases and promote them at the same time. So you can see we've got the Lions projects, and there's a bunch of these Lions that make up the microservices. And then when you deploy the Voltron project, we're going to take a particular release of each of these and put that in, and put all of those releases together into test. And when you're creating a release of the Voltron project, when you go to the create release page, or call it from the command line, you actually specify the release number of those child project releases. So, your teams are working, they're building their microservices, each one has a different release. And then at some point, on Monday, they say, here's the version of our software that's ready to go, and we want this included in the bundle for test. We're pretty confident it's going to work with everything else. And so you create a release that chooses that release of all the sub projects, and then you deploy that whole thing to test. The cool thing about this is, because it's a deployment process within Octopus, you get to specify the order that these things go out, which can be quite important, especially if some of these services are making database changes or things that are somewhat persistent, or taking services offline and online. There might be a very logical order they must go out in. And so this makes that very clear. And you can intermix other deployment steps as well, so notifications, manual approvals, etc. So The nice thing about this is the parent project only has a handful of steps. It's just deploying all those sub-projects, and each of the sub-projects shouldn't be too large either, because it's just, a service and maybe a database or something behind it. And this is how we can take that 100-step deployment process and decompose it into, 5, 10 project steps, and then another step that coordinates them or something like that.
Yeah, this is a lot of people are going through this. Actually, the Azure DevOps team shared how they kind of broke everything up and have lots of different services, but then they realized that because it's all part of one product and the documentation is for a particular version, even though that provides them the technical ability to deploy an individual piece at any point in time, and certainly for bug fixes and pre-production environments that kind of do that, when it comes to deploying to production, they always deploy all of them at the same time, just because of the nature of what they're dealing with. So there is that difference in business practicality and then technical possibilities. Well, the next question is for you as well. I've read the docs, but I can't get my head around it. What problem does multi-tenancy in Octopus solve?
Yeah, again, a case of very bad naming, isn't it? If you go to the next slide, I'll try and explain this thing. So if you think about what you're probably familiar with, most people on this webinar are familiar with in Octopus, is you have projects, which are the things that get deployed at the same time. So there'll be a process that says deploy this, deploy that, etc. And then you have environments. So if you were to draw that, you could kind of imagine that being a two-dimensional thing. You have a number of projects and they get deployed to a number of environments. The environments are like dev, test, production, etc. And so when we create a release, we're going to deploy that release of a project to an environment. The multi-tenancy features in Octopus are designed for those cases where you have the same app or roughly the same application, but you're deploying it on behalf of a number of different things. So that can be end customers. So for example, maybe you provide an energy metering service, and each energy supply company that you sign on as a customer, you're deploying an Azure database, some IoT things, websites, services, etc., that all belong to that one customer. And then when another customer signs on, you're going to deploy that entire estate a second time and a third time. That's where you would use the multi-tenancy feature in Octopus. So you'd set up each of those customers as tenants. And then when you deploy, you can see on this picture, we've got the dev environment is an untenanted thing. We just deploy to dev. We do some dev testing ourselves. And then when we were deploying to production, we're deploying it for each of these customers. So each of these customers can have their own machines. And Brian in the webinar Slack just called this out. Tenants are the third dimension exactly. So projects, environments are the two dimensions, and then tenants creates the third dimension that you're kind of seeing here. With this, you can also say things like, for the BMW example here, they have their own test environment. So if you've got customers that you work with who want to do their own QA before something goes to production, you can model that. And you can set up your life cycle so that in this case, we can't deploy to BMW's production environment until we've also deployed to BMW's test environment. This is also designed to work at scale. So for thousands of tenants, you can tag them. So you can say, here are all the tenants that are early adopters. So when we have a new release, deploy it to all the tenants that have this tag, this early adopter tag on them. You can have variables that provide different values depending on those tags. You can have deployment steps that run or don't run depending on those tags. So a good example of that would be, imagine you've got the core of your application, but then you've got these modules around it that people can opt in. So maybe you've got a CRM system, and then you've got some paid modules like, do they get calendaring support? Do they get Zoom integration? Do they get, all these, do they get a billing system or something? Those things can be modeled as variables. And when you set up a tenant, you can say, we've got this tenant that this customer we just signed on, and they have this module and this module enabled by giving them tags. And then those deployment steps will run or not run depending on those settings. Another example where this is used is brands. So sometimes companies trade under different brands. They might have the same website, but they deploy it just to different regions, or with a different brand name or something. Things that are sort of, it's pretty much the same app, but they just tweak a few settings on it. That's another case where people can use multi-tenancy.
One of the cases that we also see is in short-lived pre-production environments as well. Configuring the lifecycle. If you, in this case, you have dev, test, and production, and maybe test is a small group of stakeholders, but then somebody else needs to do some independent testing, but they need another environment. Well, it's pretty disruptive to change the life cycle of the configuration to add a test number 2. And furthermore, it might not be true. You might not need to go to dev, test, then test number 2, and then production. That's not reality. It's just that it needs to go to dev, then it needs to go to 2 different test environments in parallel, and then go to production. And so that can be useful just to set up a tenant so that another stakeholder group can have another pre-production environment of the same type, and then you deploy those in parallel so that they have environment independency, and then they come back together. So we see that a lot as well. This feature has been tremendously useful.
Yeah, it gets used and abused for lots of different things. And I think that case of provisioning short-lived environments is something we could probably model better in Octopus. But right now, this feature is really the best way to do it. You can clone environments. So one way people achieve this problem, or would solve this problem in the past, is they would just have an environment for every customer. And then obviously you can have different steps and different variables that apply depending on which environment you're deploying to. That's sort of one workaround. But imagine looking at your dashboard, it just kind of runs horizontally really, really long. And that's kind of a sign that perhaps Octopus isn't being used properly. The other way they would do it is they would set up a project and they would clone the project for each customer they sign on. You can do that if it does tend to be that each customer you sign on, maybe over time, if you're doing kind of like consultingware products where like it's the same core product, but then you change it and each customer has almost their own Git repository that you clone and you edit the code for that customer as you sign them on. Over time, those things will diverge, and so cloning the project probably makes more sense. But for most of these kind of multi-tenant scenarios, this feature works really nicely.
All right, 2 more to go.
So Jeffrey, what's the best way to handle tons and tons of variables, and any recommendations around standards for naming and casing, and what things should not be variables?
Yeah, and the number of variables is really going to be dependent on how many configuration settings and how many changes your application needs in order to be configured properly on a particular environment. If your application literally only needs a connection string to SQL Server, then it's nothing to do with Octopus Deploy when it comes to variables. It's that whether you were manually deploying this or deploying it in an automated fashion, that's the only thing that you need to change from environment to environment. Whereas if you're manually deploying your application and you have to set 100 things in order to have it function properly in an environment, well, guess what? Now you have 100 possible variables in order to configure explicitly in Octopus Deploy. But there's a lot of multiplexing that you can achieve in automated variable building, so that you don't have to have 100 scalar values even in that case. So there's configuration keys and configuration settings that can vary. They can only vary by a few vectors. They can be different for a particular application component on each different environment. They could vary by machine. If you have multiple machines in a particular environment, or even multiple machines in a particular role in an environment. They can also vary by customer. And we just talked about the tenants feature where it varies by tenant. And if they don't vary by those vectors, and it's not a secret, it's not a private credential, then you potentially could put most of those in source control. Okay. And so that would lower your surface area if you find that you're just putting it in here because it happens to, maybe you have the development values, but then you have a deployed value. So you could you could put it in source control if it's not really changing from environment to environment. Library variable sets are also useful if you find that they're the same from environment to environment, or if you can create a scheme for these variables where they can build themselves. For instance, a variable doesn't just have to be a set value. It can be templated with other variables or any of these variables that are built in. So when for instance in Azure, when creating a new database server or creating the actual database, one really useful thing is to specify the database name not as something that is known and typed in a scalar value, but specify the name as a combination of the application name and the version and maybe some other token. And that way, every time you deploy, say the TDD environment's blowing away the SQL Server database and recreating it every time you deploy to that environment, it's creating a completely unique database. And that way, you're more resilient to builds and deployments that are created from branches because you are guaranteed to not have naming conflicts. And so the more variable values that you can have generated by some type of combination of other built-in variables, the better your life is going to be, and the less that you as a human are going to have to manage those variables in an explicit way. But when it comes to specifying your mechanism for managing these variables, don't start with a library variable set by default. Refactor to it. Use the Yagni principle. You ain't going to need it. And then constantly remove the variables. If you find that the value of a variable hasn't changed across customers, environments, or machines or roles, then push it upstream and just eliminate it. Constant refactoring there. And if it needs to change later, then you can always poke it in as a new value. You want to version control as much base configuration as possible and only put in Octopus Deploy what values change frequently. And so you just think you have multiple places for config. You have config in your Git repository. You have config, baked in that doesn't differ by environment. You have config that changes by environment, stuff that changes by customer or tenant, config that changes by role or machines. And then and I also talked about having variables build themselves so that we comply with the dry principle. Don't repeat yourself. All right. And this will be our last question here. Paul, people on my team are excited to use Octopus, but our DBA insists on doing database changes manually. How do I convince them to use Octopus?
Yeah, this is common, and it is always the DBA, isn't it? Not always, but they can tend to probably have the most fears, and not fears that are unfounded either. If you imagine, for developers, our job is to change stuff. We aren't doing our job if we're not actually changing what's running in production. And for DBAs and operations folks, their job is to keep production running. And every time you change something, there's a risk that it's going to break something. Matt in the Slack just suggested that the solution would be to fire the DBA. I'm not sure I agree. I think one of the reasons why ops people and DBAs are involved in the deployment process is because they want to feel that control over what's happening in their environment. So you've all done this, right? It's time to deploy something to production. You've got all your code changes and you've got some change script that needs to run in against the database. And the process most people use is they take that script and they email it to the DBA. And then the DBA opens Management Studio. They connect hopefully to the right database in the right environment. And they take that script and they paste it in. And then, they go through Management Studio and they select each line and they read it and they understand what it's going to do and they hit F5 and they run it. And you're standing there, or you're standing behind them at their desk and you're kind of waiting, rubbing your hands, waiting for them to kind of run this change. And they're reading and they're kind of feeling like, oh, production deployment's happening. I've got to get through this quickly. But, I also need to read this and I need to understand what's going on. And this often, in most companies, in my experience, tends to be the first time they're really reading this, partly because the change script was only finished like this morning when you sent it to them. And so they haven't really had a chance to QA this before it's been run. And secondly, sometimes they'll read things before they go through, like when they're going to dev environments, they'll give you some feedback on the type of change you're wanting to make. But it's only when they're running in production they actually are kind of concerned, like, okay, I better take my time to read this. And so all of those things tend to kind of turn into these deployments either going wrong or taking a lot longer than they need to. And it stems from that need for the DBA to understand what's changing in their environment. I think the solution is to decouple those two things. So we want the DBA or the ops people or whoever is involved or whoever is on the receiving end of a deployment, let's say, we want them to keep that control over what's happening in their environment, but without them being in the process. Just like as a developer, you probably know all the steps involved in making your application run in production, how to configure IIS, where to put the files, etc., what config files to change. You need to be in control of that and you need to specify those things, but you don't want to be there on production deployment day, because that just creates a situation in which the DBAs, etc., are so busy dealing with these production deployments, they're not actually doing their job, which is administering the database, keeping it running, keeping it operationally healthy. So to decouple those things, the ideal way to do that would be, when you're making a change to the SQL schema or something, that should be a change script that you make, that you put into source control, and that's run every time you do dev and test deployments. And you get the DBA to review those, as soon as you've made the change before they start going to those environments. So you're making that an asynchronous process. The DBA can review and approve things. Ideally, if it's a pull request in GitHub or something, they can go through and comment on the change. They can understand it. They can run it themselves in their own environments. And then that change is going to happen in the dev and test environments and then production. The great thing about that is if you've run that script 15 times because you've deployed to these dev and test environments first, by the time it's time to do a production deployment, it's that exact same script that's been run in the dev and test environment. It's going to work in production. The other thing it does is it front loads thinking about changes. So as a developer, it's really tempting to say, you know what, I've got to change this model. I've got this this class and I'm just going to add a property to it, or turn this, add a couple of properties, or rename one property and split it into two or something. And you just Control RR, refactor it, rename the thing or whatever, and your change is done. And then you did that like 3 weeks ago, and now it's time to deploy that to production. And suddenly you've got to think about, how do I migrate data from the old version to the new version? If you can front load that and do it like as you're making that C# code change, make the SQL change as well. That's gonna move the model in that direction. You're going to be thinking a lot more actively about that. You're going to know what's happening, and the whole experience is going to be a lot better. So hopefully that kind of helps. You can use things like manual steps in Octopus as well to kind of say, what, here are the automated steps, and then this is the part where Barry, the DBA, needs to go and do some stuff in Management Studio for an hour, and then continue with the automated process. But that's a bit of a stopgap. The sooner you can involve these people in figuring out how to use Octopus and how to automate your deployments, the better the experience is going to be. But you've got to understand their motivations. They do make a lot of sense.
Yeah, and this is an extension of the whole DevOps consolidation, where a lot of established software companies have development and then they have operations, and sometimes the DBA is in operations, sometimes it's a third, database operations, but the companies that have embraced DevOps haven't just had the people working together, they've eliminated the divide, and they have essentially abolished the departments and created a new merged one that's just called engineering. And then in that regards, the specialist jobs have kind of gone away or been outsourced, and then everybody in there is expected to understand enough about the database, expected to understand enough about the servers, about the runtime environments, so that you don't have people that just say, no, I just write front end code, and no, it's your job to keep the database. It's not my fault. It's everybody is responsible for the software being properly designed, properly built, and properly run, soup to nuts. And so it's important in this DevOps world that essentially all of us become enough of a DBA to understand how to keep our database healthy, so that divide can't propagate.
Yeah, we need to create a movement called DevOps DBA or something, because the DevOps was that, right? It used to be, I'm a developer, I'm writing some code, and then I'm going to throw it over the wall and infrastructure take care of it. Like, I don't even know how to configure IIS. I don't know what goes in the config files. I just have some stuff I work on my desktop, and it's kind of someone else's job to figure out how to make this thing run. And then with the cloud, especially, you've kind of got this world in which you can't really go and write an app without thinking about how it's going to run in production. And so this DevOps thing is kind of being forced because developers can't really ignore what production looks like and how to handle stuff running in production.
Mm-hmm.
And right, with databases, we've kind of been doing that for a long time as well, and that's where we get all these performance problems from, and badly designed models that don't really map to the database very well.
Yeah. I think in this DevOps world, there's the software engineering group, which is responsible soup to nuts for the software. And then there are some specialists that'll always exist in the industry. For instance, just recently on a project, we went and engaged a published author on Visio as a Visio development specialist because we don't have enough of that skill set on board. And of course, we're outsourcing to Azure for the data center operations. So we don't physically go and change hard drives and check on the generators and all that stuff. So we're kind of outsourcing that specialty by using a cloud provider. And and certainly in Austin, Texas, and around the world, there are these small SQL Server specialist companies where if for your, like one of our clients with that 4 terabyte table in one of the SQL databases, it's okay, we need some solutions for managing this and breaking it up and changing it. Well, we go and tap a specialist, but the core team that you maintain where everybody's full-time salary, we need to be generalists, and everybody needs to have no shyness, no hesitation about jumping in and learning something that might be a smaller skill set. And so none of the, hey, it's not my job. We all need to have a generally good skill set across the full breadth of the technology stack that our software depends upon.
We do a similar thing. So in Octopus, there's about 30 engineers who work on the core Octopus product, and then about 5 more who work on Octopus Cloud and other things. And it works a similar way. There are people who really specialize and really love the world of security, and there'll be a channel and a team where they spend a bit of time, like 20% of their time kind of focused on security related things. So you know who to go to if you're designing something and you're kind of not sure what the security implications of it would be. But that doesn't absolve everyone on the team from needing to understand security stuff. We don't have front-end developers or back-end developers or database developers. Engineers are kind of just expected to know all of those different parts of. Our ideal thing is that developers can take either a feature or a change to the product and take it all the way from UI through to the database and what's going to happen when we roll it out onto customer machines, and we try and educate them and make sure they understand all of those parts to it. But we do the same thing when we do a major release, or when we did Octopus Cloud, we engaged some external security people who were able to bring in different knowledge and make suggestions to us that we might have missed otherwise. How do you encourage that though? Like, how do you? We're probably running on the webinar, but maybe this is a common thing for teams. How do you get people out of that silo and get them to start thinking? Because it works the other way, right? How do you get DBAs to start to think about the types of C# code they're going to be interacting with their database?
Well, that's, you ask them. I think you say this is how we need to operate. Everyone needs to be responsible across the board, not just your one little piece. And really, it's a strategy. It's a strategy of vertical integration rather than horizontal integration. And I think for when the mainframe era started several decades ago, this industry started this horizontal segmentation where I could be responsible for just keeping the storage, the hard disk up and running, and somebody else was responsible for keeping the user terminals actually connected to the mainframe. Then somebody else was responsible for this application development. And so we've created all these silos, but if you think about it, it's horizontal capabilities where you need them all to be stacked on top of each other for the user of the software to actually be able to do anything, for the software to be up and running properly. And the DevOps world is merging them all together, and because of all of the integration with other products, the entire software world has flipped from from monolithic systems that are horizontally organized to more distributed systems that are vertically organized, where for instance, Octopus Deploy, the product stays up and running, but guess what? If Azure or AWS or your data center goes down, well, guess what? The users can't really do anything. And if the source control provider that is integrated, it goes down, well, then we have issues as well. So we have all these vertical pieces that now have to fit together and integrate with each other for the software to be really useful. And the whole world is flipped on its side. But in a vertically integrated world, from front end all the way down to where the software is running, the engineers have to be reasonably adept at the whole stack. And so in order to function in that world, then there's some changes. And so if a particular person wants their career to be a specialty in just one of those horizontal slices, then that's a choice. But if you want to do that, then you probably need to choose an employer where the strategy is aligned with that specialty. For instance, I have a brother who really loves servers and maintaining servers, and even with the screwdriver and putting them in racks and all that stuff. He doesn't like the vertically integrated world, but he actually works at Rackspace. He works at a specialty data center, and that fits. I mean, he can exercise his specialty all day long. But that type of person, if you want to work at a mid-sized company that just happens to need to rent some virtual machines, but you want to be the server guy, there's just not enough of that specialty work in that type of environment. I think we got you on mute, Paul. You had a really pithy reply there.
That's so true though. So our expectation is engineers are able to learn every part of the stack, from how to do front end stuff to back end to database, through to how it's actually going to run and the performance implications of what they're doing. And that's a lot to learn. And so the way we kind of structure it is Octopus teams are split up into a particular focus area within the product. It is one big product that ships at one time, but it's one team focuses on how people model their deployments. Another team focuses on cloud specific deployments, because there's a lot of knowledge they've got to learn around Azure and AWS. And then another team focus on what happens after you click the deploy button and all the various tentacle, calamari, all the stuff that kind of has to work together. But one thing that we do is every quarter we allow teams to rotate, so people can kind of put their hand up and say, I want to go and join a different team now. I've learned a lot about what happens after the deploy button, the execution side. Now I want to go and learn about the cloud stuff within Octopus. And every quarter, we probably see 4 or 5 people switch between teams just to go and learn a different side of the product, which I think is great. It brings new skills, new knowledge to the new teams. It works really well.
Awesome. Well, we should close this out after an hour and a half of jam-packed deployment goodness.
But we're not allowed to end this without our marketing people saying we have to have a call to action. So here's your call to action. ClearMeasure will offer a 30-point pipeline inspection. What is that? What are the 30 points, Jeffrey?
Sure, I'll give some examples of the points. It's recognizing that so many people have tried to put together a DevOps pipeline at this point, and either it's working in a fantastically well manner or it has some issues. But we start at the very beginning with the organization of the source control and how the Visual Studio solution is organized within that source control, and then all the steps of continuous delivery, soup to nuts, from code and scripting organization all the way to the infrastructure that it runs on, looking at the structure of the private build, the test suite organization within that private build, now going on to the continuous integration build and how that's set up, whether it's TeamCity or Azure pipelines, how Octopus Deploy is integrated in there, the infrastructure that is set up and how that infrastructure is integrated, whether we have, even to the point of the security single sign-on or some missed opportunities there, and tentacle configurations. We look at every part to make sure that it's hooked up in the absolutely optimal configuration, and essentially provide recommendations and a plan, because in some cases it may be some things that we already take for granted because we've been doing it so many times, but it could it could mean the world. Or maybe there's just a really complex environment where we need to work collaboratively through and solve the problem. But either way, we're happy to come in and take a look and run through our complete pipeline inspection and provide our recommendations. So just reach out to us. You can go to the website, our .com/octopus, and just put in the number, or give us a phone call or email, and happy to help out.
Very cool. Thank you, Jeffrey. Thank you, everybody who's joined, everyone who's asked questions in the Slack channel. I think we've been able to keep up with most of the questions that have come up in Slack. Yeah, have a great day, everybody.
Yeah, this is fun, Paul. All right. Bye, everyone.
Thank you.